my name is Dale, and this is my channel, Observer of Anomalous Objects. And I want to go ahead and ask you, if you haven't done it already, to go ahead and hit that subscribe button. And if you like the video, make sure you hit that like button as well. For those of you that know me, this has been a pretty trying week as far as weather goes. We're hit with a terrible storm here in Northwest in Oregon, and knocked out power in a lot of areas around Portland. We got ice where I'm living, and I live on a hill. And so I was stranded on that hill for about 5 days, even fell on the ice once. I think I may have damaged my rotator cuff, but you know what? I'm here. The show must go on. And so I'm so excited because we have a special guest today coming on. His name is Jobe Soffa Clarke, and we are going to talk about something that I hadn't heard about until just recently, and that is about the collision of a planet named Theia with the Earth somewhere about 4.5 billion years ago. And so this is exciting. It's new to me. It's not a new thing, but Joby, this is new to me. So why don't you tell us a little bit about yourself, about your schooling, maybe the general area where you live, just tell us about you, or about yourself.
Hi, thanks for having me, Dale. So I graduated in 2020 in San Diego. Now I live in the Bay Area, and so luckily I haven't had any blizzards. So good luck with that. So I graduated in 2020, and ever since that, I've been essentially going down this rabbit hole of studying Earth's evolutionary history and how, we evolved, and that includes habitability. And one major aspect of habitability on Earth is Theia's collision. This idea that the creation event of Earth's moon was the result of a large collision. And what I've found in my research is that not only was this, large collision the most insane thing that happened in Earth's history, but it was also very ideal in how it happened. And there were many ways that it could have gone wrong, but it didn't go wrong. And in fact, it went right. And that's why we're here today.
I was going to say, if it didn't go right, we wouldn't be here. Looks like my camera's freezing up again. I don't get it. Well, we'll just have to tough through it. I don't know what it is. I've done everything on my end I can do, but the show must go on. Anyway, Joby, why don't you go ahead and kind of tell us about this planet Theia? What can you tell us about it?
So when we're thinking about Theia, we're thinking about the elemental composition. So there's one thing that I learned in my research is that when the sun and the solar system as a whole essentially is in its early stages, the sun, there's solar wind, and it's pushing all the gases to what's called the frost line, and that's basically Jupiter and beyond. And what happened was the sun pushed all these important elements like water, carbon, nitrogen, the things in our atmosphere today, the outer part of the solar system. So there has been this, age-old discussion of where Earth got its water and all of its volatile elements, which are necessary for life, because the sun initially pushed it all away. So basically, one idea is that Theia's elemental composition was basically, it was an icy planet with a bunch of carbon, nitrogen, and volatile elements. And that's why our planet is so abundant with this stuff that normally the sun would have pushed, because after the sun pushed all the important elements away, lucky us, some collision came just in the nick of time to bring us back these elements and then infuse them into the crust so that the sun could no longer push them away. So one thing we know about Theia, if you go on this assumption, this idea that Earth got its water and volatiles from this collision that created the moon, is that it was probably an icy planet and had a bunch of important elements that we need for life.
Okay. All right. Well, there's some other stuff I was reading about, and I'd like just to talk about it a little bit. I know you're familiar with it as well, and that is that you mentioned the moon already, and so let's go ahead and kind of go into that direction about, well, where did the moon come from? How did the moon get here? Was it here prior to Theia's collision, or was it a product of Theia's the the collision there as well. And so, explain to me your theory on that, and then I'll mention some of this other stuff. But do you see that as part of the collision itself? Is it the moon? Did it come off of Theia, or is it a combination of Theia and the Earth? What's your view on that?
So yeah, there's a lot of evidence you can look at, but the first thing is if you just look at our moon and you look at its size and compared to Earth, and then you compare that with any other moon. For example, you could look at the moon on Mars, the moons on Mars. You could look at the moons on Jupiter, the moons on Venus. All of these have, orbiting moons, and they're almost always, in terms of a size comparison, basically like pebbles compared to the planet that they're orbiting around, because that's just kind of how the solar system naturally formed. But when you look at our Earth, you find it to be highly, highly anomalous because it is so large and massive compared to Earth. And the reason why it's not like a pebble is because this is a strong evidence that it was formed in a collision. So basically the general idea is that when this massive planet hit Earth that could have been as big as Mars and probably maybe a little smaller or something like that, but it was much, larger than a standard moon. And yeah, it was a result of that collision. And then when it happened, there was a bunch of dust that was kicked up, and all of the dust eventually started orbiting Earth and eventually became the moon. So yeah, that's where our moon came from, this ginormous collision.
Well, I'm decided I'm going to do something here because my lagging is still going on, and I'm not sure why. I'll probably try to keep the picture on you most of the time. I hope that doesn't intimidate you, but it's just awkward when someone's talking and their mouth isn't matching. And as I look at it right now, it looks good. So I'm not sure why it's doing that. But anyway, if it starts lagging, I'm going to switch back to just you so people don't get frustrated. One of the theories that's out there, and it talks about the LLVP, which is the idea, it's called large low velocity providences, and it's that there is this material in total. I think they said about 10% of the Earth's surface area. It's about equivalent to that, and it's there's two different pieces of it. One is located in the Pacific Ocean, and the other one is located in Africa. And so the big question is, where did that come from? And the first theory that came up is that it was just the result of the plates hitting each other, and then over millions of years that the debris was pushed down, and eventually that's where that mass came from. The problem with that is that a lot of scientists don't believe that it could produce that much debris even over millions of years. And then another one is the idea that when Theia hit Earth, and Theia had different material makeup and maybe heavier in iron, and so the iron was heavier from Theia, and so that's why it hit there. In one of the simulations, they said it fits perfectly, and you're going to talk about that in a minute, Joby, about the angle that Theia hit, how it was kind of the perfect angle to hit to get the results that we got. But that part of it was that. Now, I think the complaint about that is that the timing is suspect, and also the mechanism of it as well, of how it could have possibly worked. And then, of course, we come to the one that fits with what Joby's saying. It's the idea that that's just part of Theia itself. That's part of when Theia hit, that it left this. Now, part of it went out. And once you kind of explain that for us, how, in your mind, how we got two separate bodies, where we have the moon now and we have the Earth, from Theia colliding with the Earth if there was no moon there prior to this.
Yeah, so that's a lot to break down, but basically what you mentioned in the beginning, I forgot the exact name, but basically what scientists have found by analyzing Earth's interior with new technology, where they can kind of send waves and then they get a response, and they can kind of look at the structures within under the crust. And what they found is that it's not just uniform. It's not just maybe if you've seen, one of the cross sections are like, oh, here's the crust and here's the mantle, and here's the this. But there's actually kind of weird looking structures, like you said, like in the Pacific or in Africa under Earth. And initially scientists thought that maybe it was a result of plate tectonics, of where the plate just like subducts into the mantle and then like drops, harder things that remain. But the other idea is that this structure under Earth is basically a remnant of evidence of this collision. And I do believe so. That is a very good explanation of why we see these structures under the crust, is that it was kind of like a remnant of the collision that kind of just stayed there and never ended up, becoming a perfect circle like, you might have seen. And then another thing you mentioned was the angle. Basically, when I have been studying this collision very deeply, and I use one model. I believe a scientist named Sarah Stewart and her team basically made a model of the collision and figuring out, all of the variables we observe today, including the moon's orbit angle, which is not 0 degrees, it's actually 5 degrees. An explanation of how that could be, because, the whole solar system always exists as a disk, and that's what we observe. We don't observe, like, for example, if you say, Earth is going this way, you would never see like Mars going this way at an angle. It's all, orbiting the sun in a disk, despite the fact that we live in 3D space. And I guess I could break down multiple things, but I guess I'll go into an explanation of that. I might as well while I'm talking about it. So the reason our solar system is in a disk is because our solar system started out as a big, like, huge cloud of gas and dust and various elements, probably mostly hydrogen. And then eventually there was something in the middle, a gravitational thing that basically became the sun and started, and then all of the dust basically coalesced into the sun. And then as it was all becoming the sun, it started spinning, because that's just like angular momentum of, like, if you're an ice skater and you put all your mass into the center, you're naturally going to spin much, much faster. So that's basically why it became a disk, is because it was all spinning. So that's the disk thing. And when you're talking about Theia's collision, bringing this back to Theia's collision, you're thinking about the angle and this collision happened, but how exactly did it happen? From what angle did Theia hit the Earth? So essentially the model that I'm going off of Stewart's model, I guess I'll call it, initially what happened is Theia hit us at a 75-degree angle. So our planet was spinning in a 75-degree angle compared to the disk, and same with our moon. But what happened was the moon, which was much farther away from Earth, was basically being dragged down to this disk, because there's much more mass in the disk. The sun is essentially dragging the moon down. And because the moon was so massive and close to Earth, it was actually interacting with Earth's spin, and basically it dragged Earth's spin, which had also initially started at 75-ish degrees, and dragged us down to 23 degrees. And this is essentially an amazing phenomenon, because not only is the moon basically stabilizing our tilt to remain at 23 degrees, which is very crucial for our seasons, because, for example, let's say we had moved to 25 degrees tomorrow, our seasons and our atmosphere would be completely different. And any life, including us, that had evolved to a specific temperature would now find themselves in a completely new environment and ill adapted to that environment. So we got basically really lucky with this collision, where not only did it hit us into an ideal angle which is 23, but it also made us stay there, which is very ideal for the evolution of life as a whole.
I thought this was interesting. I noticed if I go to single video, it doesn't seem to be lagging, so I'll just switch out that way. I thought it was kind of cool when you talked about the moon, how it stabilizes the Earth. And when you said that, the image that came to me, and I don't know if anybody else thought of this, was like a stabilizer from one of your Star Wars or Star Trek shows and stuff, that it's literally stabilizing us at a certain angle which is, what was the word for that? Obliquity?
Obliquity, yeah.
Obliquity. Okay, I almost got that one right. And so, what is the obliquity? What did you say that was?
So our obliquity is 23 degrees, and this essentially is very important because this is basically how our seasons work. So you can imagine if there was imagine that rather than 23 degrees, we were at 0 degrees. As we orbit around this disk, orbit around the sun, if this was the case, then the equator would be in a constant summer and the poles would be in a constant winter. So if we had just so happened to be 0 degrees, which was very possible because if the moon was much more massive, it would have dragged us down all the way to 0. But because our moon was very massive, but not so massive that it dragged us down to 0, we ended up at 23 once the moon was at 0. So basically how seasons work is the more atmosphere the sun's rays have to go through, the colder it will be because there'll be less sun, and the less, atmosphere, the hotter it will be. And if you analyze that in the context of the angle, if we're angled towards the sun, essentially that's where summer is, and then all the things that are lower on that, which are angled away from the sun, that's there in winter.
Okay. So yeah, I picked up something I didn't get last time we talked about it. And not only is this obliquity the perfect angle, but it's also important that the moon is the size that it is. If it was larger or smaller, would that affect the obliquity as well?
Yeah, absolutely. So this was kind of what I was mentioning. If the moon was significantly larger, just so happened like when it hit, there was a bunch of dust, and that dust gravitated towards itself and became the moon. If that moon was larger, likely its mass would have had a bigger impact on our obliquity and dragged it to 0, which would be horrible. And let's say the moon had just so happened to be lighter, that would mean our obliquity would be larger than 23 degrees. And basically, the more you go above 23 degrees, the more extreme your seasons are. So it's really hard to say, if our obliquity was larger, do we really know how life would have evolved? We don't, because, when we're talking about hurricane season, there's already, pretty decent hurricanes. And if those are even stronger, each degree you go higher, the hurricanes become worse and the blizzards become horrible, and you don't really know how Earth is going to evolve in a system. So as far as we know, it's possible that we might have just gotten the perfect angle just by lucky chance, which is very anomalous.
So is that one of the reasons like Mars has these major storms and some of the other planets because of their obliquity?
Well, Mars doesn't have a huge atmosphere, but it does have those sandstorms. One thing about Mars' obliquity is that since it doesn't have a large moon to stabilize it, it's actually been variance from like up to 10 to 15 degrees over the last millions of years. So that's one reason why Mars wouldn't have great life. But I think mostly, Mars doesn't have a big atmosphere, so there's not many weather patterns or storms. But Venus, for example, I think
That's probably the one I was thinking of.
Yeah, Venus, I believe, has a very thick atmosphere, and it would probably be highly impacted, I guess.
Yeah.
I don't know.
Yeah. Well, the interesting thing about this subject, and I brought it up before when we did this first one, is just the fact that I guess you mentioned Darwin brought this up originally, the theory of two planets colliding. But when I looked it up on AI, they call it the Big Splash, I guess is what the nickname. But it was in 1946 that a Canadian geologist by the name of Reginald Daly proposed. I'm guessing that's possibly how the moon got here, was because of this crash. Darwin brought in the idea of the planets colliding. The other thing we have to understand about these planets is because my first thought when I heard it, I thought, well, if two planets, because in some of the simulations they look almost the same size, colliding, why wouldn't one just cancel the other one out? Or maybe they'd make one big planet or something like that. But what we have to understand is that Mars is like half the size of the Earth. which is one of the reasons where we were the bigger guy, of the two, which is the reason that, we're here and Theia's not here in our place and stuff, or we're not a combination completely Theia. And although Theia, obviously, remnants, as we've talked about with the LLV piece, is here, and the moon as well. Now, one of the theories about the moon that I didn't mention this time is that there's a couple different theories that I've heard on different podcasts. And one of them is the one we're promoting right now, is the idea that Theia and Earth, the combination of the two, created the moon. But there's another one out there that people have brought up, which is interesting, is that the moon was there, but when Theia collided with the Earth, what it did was give the moon its outer crust, and I think part of the mantle would be from Theia. I don't know how you prove that, but just so that people are aware that there is another theory out there that people have on that. And so I find that very interesting. I want to get back though to the thing that you were talking about, the seasons, because I don't think people understand how important that is, because without the seasons, we wouldn't be here. I mean, we all know about the habitable zone. We know that we're kind of in that Goldilocks position from the sun. If we were, any closer, we'd be too hot to have life. If we were any further away, we'd be frozen. But what's important that Joby brings to this conversation is, we can be in the right position, from the sun, not being too far away or being too close, but without the 23% obliquity, we wouldn't be here. We couldn't be here. And what you guys have to understand, that's the reason we have 4 seasons, is because of our position on it. Whereas, what Joby was saying earlier is, if we were at 0, you'd only have 1 season, and it would either be ice cold or it would be extremely hot. We wouldn't have the changes. So I think one of the things that Joby's pointing out here, and it probably explains why we don't see life, in other planets in our solar system, is life's complicated. I mean, it's really complicated to be able to get a planet in the exact place it needs to be, at the exact angle that it needs to be, and stuff like that. Now, the one thing that we don't know about yet, we're learning more and more. There's 120 supposedly exoplanets out there, which will be interesting to see if any of them have life on them. They have the potential for life, and I think the James Webb Telescope, is what I heard recently, had shown some form of life in at least one of them. But I just want to make sure that people understand what you're saying, Joby, is that, man, life is complicated, and getting to where we are is not easy. We're somewhat of I don't want to say miracle, but in some ways we're just, we are the Cinderella story. We are but it's much more complicated than people think. Is that correct?
Absolutely. So there's a lot to talk about to respond to what you said. Now, when you're talking about life, it is true that there's no life in our solar system, and you might question, why that might be. So in terms of seasons, I think the main impact seasons had on us is the evolution of our life, is, as what I mentioned, the stability problem of the moon actually keeping our obliquity at the same exact level. And that's basically the evolution. And basically, if you say civilization, we're a civilization. And in 1 billion years, the sun will probably render our planet uninhabitable by starting to boil the oceans. So if our evolution was 30% slower, because it took 4-point-something billion years, then civilization would not exist on the planet. So the question is, how much do you change our obliquity before we evolve 30% slower? That might just be a couple degrees. But on the other hand, when you're talking about life as a whole, basically what you're talking about is abiogenesis. You're talking about the process of turning non-living matter into living matter. And that also, brings me to the point of Theia's collision, of essentially the question of, why does plate tectonics exist on Earth? Because scientists, had previously speculated, probably abiogenesis occurred in these things called hydrothermal vents. So yeah, there's these basically things under the ocean where there's like a very high concentration of elemental diversity, and basically the vents are venting up all of this complex chemistry, and the idea is possibly that created life. And what many people don't know is that hydrothermal vents are essentially a result of plate tectonics. And so what I talk about in my research, one point I make is that I speculate or have the hypothesis that plate tectonics was the reason that life exists on Earth, and it was essentially the baseline, reason for how abiogenesis occurred on the planet. Is basically the problem of energy. Right now, our ecosystem is essentially we get all of our energy from photosynthesis, plants. And basically plants are like the solar panels of our planet. The first solar panels ever invented was plants when they learned how to photosynthesize the sun's energy and turn it into sugar. But the problem with life occurring on planets is that photosynthesis is a complicated technology. Where did life get the energy before photosynthesis exists? They need chemical energy. And basically the only way you can get that is if you have a plate tectonic system where basically the elements are exposed to heat and pressure under the Earth's crust, and then eventually those elements that have been exposed to energy and basically now are free chemical energy are surfaced up in divergent boundaries, and then are exposed to heat, weathering and stuff, and then eventually they subduct back into. So it's basically like a free food machine recycling conveyor belt. And basically what I argue is that there might have been a chemical system of chemical reactions that was occurring indefinitely because its ingredients kept getting replenished by this conveyor belt, and it kept accepting this new chemistry and trying to conserve the energy. And then, this system could have been mutating for millions of years, and then eventually randomly figured out a way to drop an egg. It's not even using energy from the sun, really. It's basically using the chemical energy that is given to it for free by plate tectonics. And
before we move on, let me ask you just a quick question, because I don't want to forget it, and I think some people are going to ask it. When I say, life, that there's only life here, it's the only life that we've observed. It doesn't eliminate any possibility that there is life that's unobserved out there. But my question, which is really important, is there a time in the past, based on your study and observation, that maybe one of the other planets could have possibly been in our position, and over time, you're talking about in a billion years, the sun's going to start to boil us? And I'm guessing the reason you say that is that we're going to be getting closer to the sun, and it's going to boil our oceans. Is that correct? Or what's going to cause the oceans to boil if it's not that?
The sun is basically expanding, and
okay.
Basically we know from observing the lifetime of stars is that when they get to like the sun's age, they start to expand and become a red dwarf, I believe. And this will essentially make all of the heat get closer and closer to our atmosphere, and eventually it'll start to,
so instead of us getting closer to it, it's going to expand and get closer to us.
Yeah, so we're not moving closer to the sun. The sun is just getting bigger and more hot.
Okay, that makes sense.
And when you're talking about life on other planets, Earth is the only planet with plate tectonics. So for us to find life on another planet, that would imply that abiogenesis occurred on that planet. And as far as we know, we've only observed abiogenesis occurring on a planet with plate tectonics, and that's Earth. And, if you think about my theory, but I did want to mention, is the whole reason I was mentioning this, because it might seem like not related to Theia's collision. I do believe that Theia's collision is the main reason why plate tectonics occurred on Earth, because normally a planet's crust will harden and it'll just basically be a stationary eggshell. There's no reason that there would be plate tectonics, or there's no reason that there would be a system of plate tectonics, because that's a much higher energy state than just an eggshell of stationary crust. And basically I proposed the reason that this eggshell cracked and became a stable system of plate tectonics was basically the collision basically melted the entire crust, but then as it was hardening, it was still trying to mix. So then when the crust hardened, it hardened much faster, and the mixing was still going on, so that basically the mixing had to harden into place. And then now it's basically permanently mixing, because for it to go back to a one plate structure, it would need to break the subduction zone. And because the subduction zone never broke, now our plate tectonic system is basically lasting indefinitely.
Okay. And another thing you mentioned before was, in our solar system anyway, as best to our knowledge, we are the only one with tectonic plates. Everything else is like that eggshell that you described prior to, Theia hitting Earth, correct?
Yeah, that's correct.
Okay. Good stuff. All right. The next thing you were going to talk about, the plates, what was the fourth point? I was trying to remember on your video as you went back, the subduction zone or whatever. I never can get that word right. Subduction zone.
Subduction zones.
Yeah, for whatever reason, that's a word that just doesn't like my lips. Anyway, so what was the next thing that was under that point? Was it 0.4 or was that 0.4 on your list?
Well, so I guess correct me if I'm wrong, but so I guess the main points of the entire collision are, number one is elements. Theia had to have like water and carbon and the right elements, and it was
we haven't got to that yet.
I'm not sure if we talked about. And then there's the seasons of the obliquity, and then there's plate tectonics. So I guess the points I made about plate tectonics was, number one is that Theia's collision probably caused plate tectonics, and number two is that plate tectonics caused abiogenesis. So those were the 2 points I made about plate tectonics. And then I guess if you're talking about more points on the argument of how exactly Theia's collision would have caused that, is basically you can look at basically the higher energy state, the crust would need to be cracked in some way, and the idea of the mixing of elements and then the crust hardening, and then it became a permanent system. And then I guess there's other points where you could say all the possibilities of what plate tectonics does for the ecosystem. So number one is abiogenesis, and you can also look at recycling. So like when a life form dies, it's likely that a lot of the chemistry will no longer be able to be used by other life forms, because it's like basically spent material. So lucky us, the plate tectonics is also a natural recycling machine. So it's like, nowadays, we pay people to drive and then they take our recycling. But, before, you can hire someone, you actually need the planet to recycle itself, because if there's a bunch of dead life forms and no one can use their matter, it's going to pollute the entire planet. And now plate tectonics recycles that for us. And there's also, the
so that would be another.
And then there's the there's other things, like if you go down that plate tectonics rabbit hole, there's a bunch of benefits that plate tectonics does to our ecosystem.
So that would also add to the idea of one more thing to look at as far as about why we're different than the other planets around us, is the fact that the planet cleans up after itself even. Yep. And stuff. So it's pretty exciting. Let's take a step back for a minute, because there's something that we haven't talked about that I thought was interesting, because a lot of people are going to look at our planet and then they're going to look at all the other planets around us, and I guess some of them they're discovering ice on and water, but there's no blue marble out there in our solar system that looks like us. And so the question is that the old theory, should I say, before I add the question, the old theory was the water came from a bunch of asteroids hitting us. And but that's a lot of asteroids, and I get the idea they're going to break up in the atmosphere. In fact, if you want to look at the difference between the moon and the Earth, the reason why we don't have all those potholes all over the place is because our atmosphere burns up a lot of them as they come in. But the question is that with a bunch of asteroids, I mean, this is a lot of water. And even I'll say this, even when you add Theia's collision, which was Joby, you told me earlier that was probably an ice planet, and that probably explains to it, but that's probably the best explanation that I've heard so far for where all the water came from, because it seems like a stretch to believe that a bunch of asteroids by themselves gave us this much water. And so, why don't you go ahead and explain to us, about Theia and how it affected the amount of water we have, and what's it like? I think we said this earlier. Isn't it somewhere around 75% of the surface of the Earth is water, somewhere around there?
Yeah, something like that. So it basically goes down to the age-old question of where Earth got its water, because as scientists figured out, when the solar system first formed, basically the sun, it had very excessive solar wind that was pushing all the gases to the outer solar system, basically Jupiter and all the gas giants, pushing the gas all the way to the gas giants, right? But at those temperatures, water, carbon, nitrogen, these are elements we need for life. These are gases at the temperatures on the surface. So basically the sun is pushing all these important gases that we really want. They're like, no, gases, come back. Push it all the way to the gas giants. And, now we're just now we're basically Mars. Where's all our water? So basically the idea is how we actually got water, because this is going to happen in all solar systems, is that Theia was an icy planet, and then it infused all of the water and volatiles that got pushed away, and it infused it into the crust. So now the solar wind can no longer push it to the edge, because it's been basically shoved into our crust by this ginormous collision. And that is what many studies have been basically attributing to, like, where we got our water, because the old idea, like, oh, we probably just got it from asteroids. This idea, when you actually start doing simulations, saying, like, how many asteroids would I need to get this much dang water? And it turns out, if you compare our gravity, any planet is going to get asteroids compared to its, like, in proportion to its gravity. Earth simply doesn't have that much gravity to get all these asteroids. Like Mars would have stolen some, Venus would have stolen some, and Jupiter, the gigantic planet, would have stolen the vast majority of the asteroids in our solar system. So to argue that Earth got water from asteroids is questionable. And Theia's collision basically is the answer to this puzzle of how we could have gotten so much water and held onto it.
Especially if it was an ice planet, that would really come a long way. Now, one of the things I wanted to mention to the audience as well is that what Joby's saying, a lot of simulations have been run. It was a combination of Arizona State University and the University of Chicago. They used a supercomputer, and I forgot how much faster it is, but you know, supercomputers, they're way faster than the human mind, than humans can calculate. And when we get to quantum mechanics, can you imagine what these simulations are going to look like? But they basically came out with the same, at least some of the simulations came out very much with what Joby's saying. Now, the one thing they did say that I want to put in as a caveat when you talk about these simulations is that they are not conclusive. And so that's why we're talking theory here and not fact. But it's an educated theory. It's a theory that has not, Joby wasn't the first one to bring this up. He's just refining it to bring it up. But there's been a lot of great minds before him that have also looked at this as well, Darwin and others. And so I just wanted to use that. In fact, it was published in the Journal of Nature. And so this is not just somebody bringing up some crazy ideas. I mentioned before, Darwin was one that brought it up first, and then the idea of the moon being created, it seems like that came from, Reginald Daly in 1946. It's pretty good. I think I'm going to go ahead and add something to this video just to give us a little more depth on it. And it may not be, everybody may not agree on this, but on the Fermi paradox, I know there's a lot of people that will look at it, and I'll just speak for them for a minute. The Fermi paradox is the question of, if there's so much life out there, the premise of it is, then why don't we see it? Why isn't it more abundant? And what I want to do is I want Joby to be able to say, assuming that's true, understanding that there's a lot of questions that people have about it, and I have my own questions about it. So we're just going to tie it, if it's true, then that would also help explain the importance of Theia's collision. Is that would that be your premise on that?
Yeah, absolutely. So you can make the connection of, where are the where are the radio signals from all the civilization? Where are the biosignatures from life? We're having trouble finding it, even though we have all these amazing telescopes. Yet we haven't found the conclusive evidence of, oh, there's a star like 50 light years away and we found life and we know it's life. No one has actually found that biosignature. No one has found that thing. And so one idea could be like, oh, perhaps the reason we don't see the life is because it's simply not there. Because, when you look at our history, you see all the, the hoops we had to go through and all the luck, because, what if Theia's collision had produced a larger moon? Then we're doomed. What if the Theia's collision had produced a smaller moon? Then we're doomed. What if Theia didn't have any water and now we have no water and now we're doomed? So basically, you look at the statistical probability and you're like, perhaps life is more rare than we had initially thought.
Yeah, those on the other side. And in fact, Steve Bassett asked me to maybe ask you this question. Have you thought about all of the eyewitness accounts of people that have, had encounters from what they believe to be beings who even told them that they were beings from other planets? I mean, that's one of the things that, like I said, one of my issues with the Fermi paradox is it assumes that life is not plentiful. And I get it. What science want is, they want the ship, they want the actual person. But I think this is one of the things that my community struggles with. And this is one of the complications between, those of us who believe that life is visiting us. We don't know what it is. We don't know if it's extraterrestrial. We don't know if it's in some other form, which is, I was going to get to your radio signals. There's a couple things that I thought about, and maybe they're not the best arguments, but what if the radio signals from the different planets, what if they are in tune with the planet itself? And so you couldn't tell it because it's the same signal. What if unlike us, and this is one of the questions I had, and like I said, it may not be valid, but we went out there and, we put the message out there. Hey, we're out here, we sent the Voyager out there and stuff. And some have argued maybe that's not the best thing that we could have done. If there's life out there and it's more advanced than we are, and if it's hostile, we're just setting ourselves up to be taken over and destroyed. So what if the possibility there's other life out there that doesn't exactly want anyone to know it's there? And so that's another possibility. But I think the bottom line is, this is the stuff that I would bring up is I understand there's a kind of divide between science and those of us who are in the UAP community. But I'll have to say this, it seems like there are more and more scientists coming on board and taking this issue seriously. And our government's taking it seriously, that there's something, we don't know what it is. They've changed the word from UFO to UAP, unidentified anomalous phenomenon. But, they've gotten various platforms where they've seen things, the Navy has seen them, where something's flying around in military restricted airspace, doing things that we don't have the technology at this time to do. It's way beyond. We don't believe that our allies have it. We don't believe that our enemies have it. They've taken it so seriously that they've set up UAP offices to investigate, because there's clearly something going on. Congress isn't going to get involved and put their reputations at risk if there isn't something to it. And they had ATIP before anybody knew about it, and the contract with ASOP. They have AIMSOG. Then they went to the UAP task force, and now we've got ARROW, the All Domain and Anomaly Resolution Office. And then when you add on top of that, then you've got 3 different congressional hearings where this has been brought up in Congress, 2 in the House and 1 in the Senate. And then when you add on top of that the thousands upon thousands of people who've seen things, and I will agree with anybody. Some of those may be misidentifications. Some of those things may be people that are not stable, but there are enough of them that are by credible people that there is something going on. And so that's my only issue with the Fermi paradox. I understand. I think everything you said is true. And I think it does show, that life is rare. But the problem is somebody or something is visiting us. And so is it as rare as the Fermi paradox claims it is? And I understand from your view and from a scientific view, it's harder to substantiate that. But I do want to say this, and it's called anecdotal evidence. And so the word evidence is put behind that. It's not necessarily scientific evidence, but Joby, one of the things I think is really interesting and really going to help in this bringing science into this and investigating it, because that's one thing science hasn't done in the past. I think they're starting to do it now, but there's a soul foundation that's been started. And I think Dr. Gary Nolan was one of the ones from Stanford University. He's one of the ones that had started that. And that's to get the intellectuals, to get actual peer reviews done on some of this stuff, and not just people commentating about it, but actually get the scientific world involved in it. But anyway, so I'm not criticizing the Fermi paradox. I just see some problems in it, but I see how it fits perfectly with what you're saying too. And so I'm not trying to in any way knock it. I'm just saying there's a, like we talked earlier about the moon. There's a couple different theories on exactly, was the moon here, or did it come later? Was it created, basically by the collision, or was it here and did the collision just somehow change the outer parts of it? And so I'm not, like I said, I'm not trying to be negative in any way, but my community, we just feel like the subject has been ignored for way too long by the scientific community. And we're really excited because there are more and more scientists saying, you know what, we should give this a serious look. I mean, there is data to look at, and we don't have the spaceship, on the White House front lawn, but there sure seems to be enough evidence from credible people, including military pilots and others, credible people, that it ought to at least be looked at and stuff. So anyway, I talked too long. I apologize for that, but I did want to make sure that the other side of the Fermi paradox was heard.
Yeah, I mean, I can talk about that. I mean, you're right. I mean, the sheer number of sightings is undeniable, and the the craft are flying in our atmosphere, and it doesn't seem like anyone has a plausible explanation for what's going on. Like my initial thought was, if a civilization, so if these craft are alien, if these are extraterrestrials, we're talking about extraterrestrial civilization, no doubt, because you need a civilization
to
build
be honest with you, Joe, to be honest with you, that's not the main focus for a lot of people anymore. There's a new term that's being used for it, and it's all encompassing, and it's called NHI, non-human intelligence. And so there are people that think they're interdimensional, all kinds of different, things. I think the only one that wouldn't fit in that category is possibly time travelers, because if it's time travelers and it's us coming back to try to save us, then that wouldn't be non-human. But so to be clear, there are going to be some people watching this video, and a lot of people are moving to interdimensional. That's kind of the thing that people are moving to. And I'm not saying that's any better than extraterrestrial. I'm just saying it may not be strictly from another planet. It may be from another dimension. I don't know. That's where I say we're all in speculation at this point.
Well, if anything, it would actually make more sense for it to be interdimensional. If you look at the alternative with, let's say it was a distant star, and if that star had created a civilization, and then that civilization had flown their ships all the way over here, their star, just based on probability alone, would be many, 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 many light years away. So like we're talking about ginormous distances, right? And if you look at our spaceships, it would take 50,000s of years just to go one light year. So if perhaps a civilization had made some sort of technology that was able to, for example, take advantage of wormholes, take advantage of space-time manipulation, and figure out a way to transport through space that wasn't actually literally flying through space, then these interdimensional beings, that would actually be a better explanation, because if there was a civilization, we would have seen their radio signals much before we saw their ships, and we don't see any radio signals. So it's hard to believe that these ships had flown from like gazillion light years away to come to us. So that's why interdimensional isn't such a horrible idea if someone figured out how to teleport or something like that. it would make sense why we didn't see that.
Couldn't ET use the same principles though of interdimensional?
Pardon me?
Couldn't ETs or some other planet use that same principle though that you just described, interdimensional?
That's what I'm saying. So if it was some sort of ET and they figured out how to, use a wormhole like Einstein says is physically possible, then yeah, they would make sense. And that would be a reason of why we don't see the radio signals, because they didn't ever have the time to travel to us. It was just, interdimensional.
How far can we pick up radio signals from? That's the next question.
They should theoretically
maximum distance that we know.
Definitely.
Because I mean, we've got one galaxy here, and what is it? We're almost up to 1 trillion galaxies now. So the probability that we're the only life in 1 trillion galaxies, when we, like I said, we know we have 120 exoplanets that we haven't even explored and looked at yet, and maybe they're more primitive than we are. Maybe they haven't developed radios yet, or technology that would do that. But I think most scientists will agree with this. The probability that we're the only planet in the universe with life is almost zero. The issue is what you brought up, is how can they get here? That's the real question that I think most scientists struggle with. But hopefully, like I said, you're pretty open. I appreciate that, you at least know the arguments for the wormhole. There's, the hard part, I think, is that we can only look at this argument or this discussion from our own vantage point, from our own base of knowledge. We know there's probably so much more out there that we don't know and we can't even comprehend right now. Imagine going back into the 1800s and trying to explain a computer, or even, some of the stuff we've talked about today. Just imagine how they would take that and not be able to comprehend it. And so, we're talking, a couple hundred years, and look how far we've come. In fact, in the last 60 or 70 years, I'm excited to see where we'll be in the next 60 or 70 years, as far as our understanding of things. And so that's one thing I would put a little bit of a balance on, is that we're looking at it through a certain filter of what knowledge we have, and we are growing and we are evolving. And I have to believe that any civilization that could be 1 million years, 100,000 years, whatever, or even older than us, the leaps and bounds that they could make, I don't know. And like I said, will they have physical bodies by then? I don't know. Those are the big questions that we don't have an answer for. Well, anyway, Joby, was there any more you wanted to bring in about either the Fermi paradox or the Theia collision, or are you pretty much satisfied that you presented what you wanted to present today?
Yeah, as far as Theia's collision, I think we definitely hit the main points, and maybe we'll have a conversation about other areas of this, basically this deep rabbit hole of aliens and extraterrestrial life and statistical probabilities. But yeah, I think as for Theia's collision, I think we basically
okay. I appreciate you. You've definitely been a gentleman, and like I said, we maybe don't understand everything exactly alike, but we agree that we should be studying this stuff. We should be investigating it and trying to unlock some of these secrets. And they may not be what we think they are, but we at least ought to look into them.
Absolutely, yeah.
All right. Well, thank you, Joby. Sure appreciate being here. Looks like my voice is not connected again. We had internet go out yesterday, and I have a feeling it either damaged the modem or the fact it's just internet's not working properly right now, and they're maybe still trying to get everything back up to 100%. Anyway, thank you so much, Joby, for being here, and we'll have to have you back on and have another interesting conversation. Okay.
All right, then. Thanks for having me.
All right. Bye.